Teaching Blast technical seminars are an Intertech production. For instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.
So we've installed the platform, and again, really high level here. The platform can be broken down into these three components. And I've already mentioned those two, right? Remember that the CLR, that is the runtime environment that will host your applications. And he's the guy doing all the heavy lifting, right? It's going to help you out with your threading. It's going to be managing memory for you. So there's a garbage collector, just like we have in Java, for example. It also will be kind of abstracting away the file system. So it's kind of doing that grunt work. Remember, the common type system is a very, very rich specification that says here's every single possible thing that the runtime could do. And that's the operative word, could do. But now look over here. Okay, here are some different .NET languages that can target the platform. And this is actually not a typo, believe it or not. There's actually a COBOL version of .NET. Well, when you just think about it real practically, you'd probably agree that, okay, COBOL is probably not going to be as feature-rich as C#. And here's one example. In C#, you can actually declare and manipulate pointers. Now, most people never use that feature, but it can be done. In COBOL, you can't, right? So basically, the common type system says, yes, pointers are possible. But look at this little box inside of the common type system called the CLS, the Common Language Specification, right? Think of this as a true subset of the CTS, right? This describes all of the features that a .NET language must do at minimum to play the game. So, if you are writing software with C#, which can do things outside of the CLS, such as pointers, if you want to make sure that any language can use you seamlessly, you're going to want to stick inside that little box. Now, thankfully, it's a pretty big box, though. You're really not losing much if you build CLS compliant software. Some of the more esoteric things are stripped away, again, just to have better language interop. So here's kind of, again, a little hit list on those terms and a couple of new ones. So why don't we look at these last two little subpoints here. The Windows operating system for years has had these two common file extensions, DLL and EXE. Now, a .NET application will typically take these exact same file extensions, but the internal composition is completely different. So here's a term for you, assembly. All an assembly means is that you have a DLL or an EXE that was built with a .NET compiler, like the C# compiler. What makes an assembly different from a typical PE COF file format is that we have SIL code inside of it. Okay? Now, SIL code also goes by terms such as MISL, Microsoft, IL. Sometimes it's just simply called IL. Common Intermediate Language is conceptually similar to Java bytecode in that it cannot be directly executed. It has to be compiled on the fly into actual platform-specific instructions. Now, there are a lot of different ways to kind of interact with that process, but no matter which high-level language you pick, COBOL.NET, C#, C++, CLI, the compilers always generate this SIL code. Now, I'm going to show you a demo coming up pretty soon where I'll actually show you what that SIL code looks like, at least a tokenized version of the binary format. Now, let's talk just a little bit about this common type system again. Thankfully, programmers like us, we don't have to worry about memorizing every single rule of the CTS. But if you were a person building a compiler, then you're very interested in this, because you want to make sure that your compiler is adhering to those ECMA specifications, right? Now, even though we don't have to memorize all these rules, let me just kind of show you a couple things that can be helpful to know. Now, you might remember earlier in this video, I said that every .NET language is free to define any keyword they want for fundamental data types. But in the background, they're always pointing to the same thing. So here's a classic example. Simple numerical data, the int. Okay? And we'll look at C# versus VB, for example. These two languages have different keywords for the same underlying data type, right? So when a C# programmer were to say something like int I equals 0, what they really said was system.int32i, okay? Likewise, if a Visual Basic programmer says dim I as integer, what they really said was dim I as system.int32. Now you might say to yourself, well, why do I care about that? Well, the good news is, because we have a common type system, we don't have to worry about things like overflow, underflow, right? We don't have to worry about, well, how big is an integer in this language? In any .NET language, an integer is the same size. And all these different .NET types that we see listed here in the first column, these are actual real types with real methods and real properties that you can call, right? So you could say things such as, well, let me pull up Notepad and show you. I'll even show it to you in Visual Studio so you can get the more dramatic effect with the IntelliSense. Let me just fire up Visual Studio real quick here. I'll be running 2010. And I will go ahead and I'll just make a console project. Keep it simple, right? So file, new project. There's the console type. Since we're here, why don't I just kind of point out a couple of things real quick for you. Visual Studio can host a variety of different programming languages. So you can see that on my machine, my default language is C#, but there are plenty of other languages that I can pick from as well. And if you buy third-party languages, you'll see them listed here as well. Also notice that Visual Studio has support for doing Windows Phone development. We can do Silverlight programming, cloud computing, but we'll just, again, stick with the nice simple console program. I'll just call it Video Demo 1. Now what I was going to just write a little code here to show you again was this relationship between keywords and .NET data types, right? So remember, when I go ahead and say int I equals 0, that is functionally equivalent to saying system.int32, I'll call it I2, equal new system.int32. Okay? Now, certainly, if you have a keyword, you'll probably want to use your keyword, right? Much less typing. But notice in both cases here, if I were to say I dot, notice how that integer has real functionality for me. So I could say to it, well, what type of thing are you? Here, I'll print that out to the console. So I'm just going to print out the fully qualified name of what that thing is. I could also ask this guy, well, who are you? Right? So if I were to compile and run this program right now, notice how, in both cases, I'm operating on the same underlying data type, a system.int32. And if I were to write the same kind of code in Visual Basic, where I said, dim I as integer, it would still say system.int32. And also be aware that the int, which is just the same thing as system.int32, it has a bunch of members that are static as well. So notice how I can ask an integer, how big are you? How small are you? We have a handy parse method. I won't go into all these little situations here, but I just want to point that out because this is very different from systems like Java, right? In Java, the int is a special token for the Java runtime. If you want to treat the int as an object, you have to box it up. Nowadays we have auto boxing, but it still needs to be coerced. And here we have this interesting illusion where we can treat everything like an object, even though the runtime is smart enough to handle memory management appropriately. In the full class, we have a module that talks about this distinction between a value type and a reference type. We talk about boxing and unboxing, talk about ways to optimize that. But from a practical point of view, it's a nice feature, right? I can just pretend we're all objects. I could even write code like this. I could say 23 dot toString. Actually, why don't we do this here? 23 dot get hash code. And I'll put that in a console.writeLine. Now, this is almost a little bit small talk like, right? The ability to say, well, I want to go ahead and just create something and call members on it. So let's run this. Now, don't even worry about what get hash code is all about. The bigger point to focus on here is that I was able to take a numerical piece of data and invoke the same members on it, right? And that's because if we kind of follow the winding road, that 23 is actually mapping to a system.int32, which is then extending something called system.object. So I have a very symmetrical framework here. I'll come back to Visual Studio just a little bit. But hopefully you kind of get what this little chart was trying to illustrate there.
For more free learning resources and to see the latest lineup of our instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.